Chapter 9.1 deals with monomials. And when it talks about monomials, it is dealing mostly with monomials in one variable or letter in the expression ax to the nth, where a is the numerical coefficient and n is the degree of the monomial. We would refer to n as the exponent, but it also indicates the degree. So if you had 16x squared, your numerical coefficient would be 16, and the degree of the monomial would be 2. If you had x to the fourth, when there's nothing in front of the x, the numerical coefficient is simply 1. It is not 0, because if you had 0 there, there'd be no value whatsoever. So it's basically 1x to the fourth. 1 would be the coefficient, and 4 would be the degree. If you had negative 2y to the ninth, the numerical coefficient would be negative 2, and the degree of the monomial would be 9. 1.5x, the numerical coefficient is 1.5, and then your degree, you don't see a number, it's going to be 1, not 0, okay? It's 1.5x to the 1, and 1 would be the degree. Now, 0 is also considered a monomial, okay? And you're going to have to bear with me here. But 0 is considered a monomial because it could equal 0x to the 1, or it could even be 0x to the 2, or 0x to the 3, or so on. It could be nearly anything, right? Because when we see 0, it's still going to equal 0 no matter what x is to what degree. So, however, we don't consider 0 as having a specific degree because it could be anything, as we've just demonstrated. Likewise, a number such as 3 or 2/5 or -8 can also be monomials. In fact, they are monomials because they could be written this way. It could be 3x to the 0, or 2/5 x to the 0, or -8 x to the 0. Okay, which would still be, if it's x to the 0, we know that equals 1 because anything to the 0 exponent equals 1, except for 0, of course. We learned that in last chapter. So because of that, we consider 3 and 2/5 and -8 and any constants or numbers that stand alone as monomials. And the degree of these monomials is 0. The degree of a 0 is, it's not defined because it could be anything. But for any other number, the degree of it would be considered 0. Now let me talk to you because you are going to get strings of monomials together. And if you have 2 or more monomials in the same variable to the same degree, and they're being added or subtracted, their sum or difference can be written as a monomial. For instance, if you had 3x plus 4x, well, that's the same thing as 7x's. Now, 7x is a monomial. This combination is not as it exists, okay? As far as having a plus sign or a minus sign shows that it is not a monomial. But if they can be combined into a monomial, then they are considered one. Okay, likewise, 6x squared minus x squared is going to be 5x squared, a monomial. 2x cubed minus 2x squared, however, they are not alike. So there's no other way to write it, and it is not possible to write it as a monomial. So if you are being asked if this can be written as a monomial, you would say no, it is not possible. Now, like we just showed you, if you have varying degrees for a variable, you can't add or subtract them. There's no way to express x squared plus x cubed as a monomial. It just is not possible. However, you can express x squared times x cubed. In other words, you can multiply monomials with different degrees and even different variables and still get an answer. In this case, your x squared times x cubed would be x to the 2 plus 3, as we learned in Chapter 8, which would be x to the 5th. So we are able to combine multiplication into a monomial, even when the degrees are different. Let's show you some more examples. If you had 3x to the 5th plus x to the 5th, you'll end up simply with 4x to the 5th, which is a monomial. If you have 2x to the 6th minus x squared, your degrees are different. So you cannot express it as a monomial because it is a subtraction problem. If you had 4x cubed times 6x to the 7th, now this is multiplication. So we can express 4 times 6, which equals 24. And then x to the 3 times x to the 7 is x to the 3 plus 7, or x to the 10th. And if we have this, we know from Chapter 8 that we can apply this exponent to everything that is in the parentheses. So it's the same as negative 2 cubed, and we'll put that in parentheses still, so you know the negative is part of it. And then x to the 4 times 3, or x to the 12th. And of course, because this is pretty simple math, you can do negative 2 cubed, which equals negative 8, and then you'd have your x to the 12th. And that, I think, is all we need to do. You do need to remember your laws and the definitions that you learned from Chapter 8, because you will be applying them, as you can already see just in these examples, as we go along. Have some fun!